Hey everyone, and welcome back to another explainer. Today, we are unpacking a topic that is literally foundational for anyone using any kind of digital device, and that is computer memory. Now, I know a lot of you already follow tech pretty closely, but whether you're prepping for a major computer science exam or you just want a much clearer, under-the-hood picture of what is actually going on inside your machine when you push it to its limits, you are in the right place. We're going to break down everything from the absolute basics of storage all the way up to RAM, ROM, and beyond. So let's get right to it. To really kick things off, let's think about a process we all do 100 times a day. Have you ever wondered where the computer actually keeps a file, a program, or a piece of information right at the exact moment we open it? Think about it. You double-click an icon, and boom, your heavy editing application or your favorite game is just right there on the screen. But where was it hiding before you clicked? And more importantly, where does it sit while you're actively working on it, moving things around and making changes? And here is an even more interesting hypothetical question to consider. If a computer had absolutely no memory at all, would it be able to function properly? The short answer is absolutely not. No way. Memory plays an incredibly crucial role in dictating a computer's overall speed and performance. Without it, your unbelievably fast, hyper-powerful central processing unit would just sit there. It would be completely paralyzed, twiddling its digital thumbs, with absolutely nothing to do and nowhere to put anything. Okay, so here is our roadmap for today's explainer. 1. The need for memory. 2. Measuring memory units. 3. RAM versus ROM. 4. Programmable ROM variations. And finally, 5. Final exam summary. Section 1. The need for memory. Why computers need storage. Before we start throwing around acronyms and categorizing different chips, we really have to understand what memory actually is and why a computer system fundamentally demands it in the first place. In very simple terms, computer memory is the dedicated space where a computer stores data, instructions, and programs for the CPU to execute. It's essentially the staging ground. Whenever the central processing unit runs a program, it absolutely requires specific data and specific instructions to make that happen. The memory steps up to the plate to help the CPU access all of that required information instantly. And we can use an analogy here that brilliantly illustrates why having local, easily accessible memory is so incredibly vital. Imagine you're studying for a huge final exam from a textbook, and you are sitting inside a massive, sprawling library filled with thousands and thousands of other books. But instead of having your research materials piled right there at your desk where you can just grab them, what if you had to physically stand up and walk to the exact opposite corner of this enormous building for every single tiny piece of information you needed? You read one sentence, walk all the way back to your desk, write it down, and then walk all the way back across the building for the next sentence. Your workflow would be unbelievably slow. You'd spend literally all your time just walking around and barely any time actually studying. Well, in the exact same way, a computer needs memory located very close by so the CPU can quickly grab required data and instructions without constantly walking across the library, so to speak. This dynamic is what makes memory one of the single most important components of the entire computer architecture. Section 2. Measuring memory units. From basic bits to terabytes. Just like we measure physical distance in miles or kilometers, or liquids in gallons or liters, we have to have a way to measure digital information. The absolute most basic fundamental unit of data in any computer system is called a bit. A single bit can only hold one of two possible values, a 0 or a 1. It's essentially an on or off switch. That's it. It sounds wildly simple, right? But literally every massive document, high-definition video, and complex application on your computer is eventually broken all the way down into these tiny zeros and ones. So, how do we build up from that tiny individual bit to the massive hard drives we use today? Well, for those of you taking exams on this, you're definitely going to want to lock this progression into your brain. If you group exactly 8 bits together, you get 1 byte. From there, we start scaling up massively. We go to kilobytes, then megabytes, then gigabytes, and finally terabytes. It is absolutely essential to remember that exact sequence: bit, byte, KB, MB, GB, TB. That's the core ladder of digital storage. Moving right along to Section 3, RAM versus ROM, the core conflict of temporary and permanent. You might be wondering, is all memory exactly the same? Not even close. Some memory is totally temporary. It's easily read, written over, and changed, while other memory is strictly permanent and really shouldn't ever be modified under normal everyday circumstances. So, the crucial point for us to understand here is this exact contrast. Let's look at RAM first, which stands for Random Access Memory. RAM acts as the computer's active working memory. The key word you need to know here is volatile. That means if the power gets shut off suddenly, all the data sitting in RAM is generally lost forever. Think about when you're typing a long document and before you hit save, the power suddenly cuts out in your house. When you reboot, that unsaved info is just gone. That's RAM in action. On the exact opposite side is ROM, or read-only memory. ROM is non-volatile. That means even after the power is completely turned off, the crucial instructions needed for the computer's most basic foundational functions remain totally safe and intact. Now, if those technical terms are feeling a bit abstract, let's ground the whole thing with a really relatable real-life example. Imagine you're sitting at your study table tackling tonight's homework. You have a spiral notebook open, you are actively scribbling down math calculations, erasing mistakes, rewriting things, and just working actively. That active, messy notebook is your RAM. It's for your current, immediate working tasks. But sitting right nearby on that exact same table is a heavy, printed, hardcover textbook filled with permanent rules and formulas that you reference again and again. You don't write in it, you don't erase things in it, you just read from it. That printed textbook is your ROM. Conceptually, it's permanent. Its information is totally secure and survives even when your homework session ends and you pack up your desk. So always remember this distinction. RAM is your working, temporary memory, and ROM is your non-volatile, permanent memory. Section 4. Programmable ROM variations, one-time use and erasable. Technology obviously didn't just stop at basic ROM. Engineers quickly realized they needed way more flexibility than a totally unchangeable chip could offer, which led to some really cool advanced versions of read-only memory. First up, we have PROM, which stands for Programmable Read-Only Memory. The huge key here is that PROM is actually manufactured as a totally blank slate, but it can be programmed exactly once by the user or manufacturer. Once that specific information is officially burned or written into it, it's locked. It cannot easily be changed through any normal means. It's strictly a one-time programmable memory. But then we have EPROM. Just look at the name, Erasable Programmable Read-Only Memory. The name totally gives away its most important feature. Unlike standard PROM, an EPROM chip can actually be completely erased, usually using strong ultraviolet light, and then reprogrammed entirely from scratch. Let's bring our trusty study table analogy back just to absolutely lock this concept in. Imagine a very special notebook sitting on your desk. For PROM, imagine you are writing your notes in thick, permanent ink. You have the freedom to officially program that notebook once, but after that ink dries, it is set in stone. You can't easily change it without ruining the page. For EPROM, on the other hand, imagine a notebook where you only write in pencil. If you make a mistake, or if the information gets outdated and you need a software update, you can just grab an eraser, wipe those pages completely clean, and write something brand new. That is the exact fundamental difference between one-time use PROM and the highly flexible, erasable EPROM. Section 5. Final Exam Summary. Key takeaways for your studies. We have covered some genuinely fantastic ground today, breaking down the true architecture of how our machines think and store data. If you have an exam coming up, or if you just want to ensure you perfectly retain what we learned today, this is the exact moment to focus. Consider this your mental screenshot. First, the CPU absolutely relies on local memory for its speed. Otherwise, remember, it's stuck walking miles across that giant library. Second, RAM is your temporary, highly volatile working memory. Third, ROM is your permanent, non-volatile memory meant for basic system functions. Fourth, PROM is a specialized read-only memory that can be programmed exactly one time. And fifth, EPROM gives you that awesome flexibility to erase and reprogram the chip when needed. Keep those core differences crystal clear in your mind, and you will totally nail this topic. Well, that brings us to the end of our explainer on core memory concepts. I really hope this breakdown made the sometimes confusing differences absolutely crystal clear for you. But before we wrap up today, consider this provocative little question. Do you want a separate, hyper-focused explainer covering just the deep dive differences between RAM, ROM, PROM, and EPROM? Let us know what you think. Keep learning, keep asking those great questions, and I will see you all in the next explainer.